Hello, ClockHacks. My name is Danny Darden, and I am a computer and information technology professor at Kilgore College. And I want to thank you for coming to this session on cybersecurity, protecting your programming data. And I want to talk to you about cybersecurity and give you a little bit of information about some things. We're going to look at maybe a well-known attack that you've already seen before, but it's called a buffer overflow. But first, I want to tell you a little bit about a little school in Texas where we're at in Kilgore College. And so we'll just give you a little bit of information about going to school and maybe a small town, maybe something that you've thought about before, but have always thought, well, why would I want to study in a small town? And this is kind of an idea of that. And um, you can see how it is living in Texas. Many of you are from other parts of the country, and so you've heard of Texas before. But this is um, a good place. There's a lot of uh, people here that are friendly. We're happy to be in Texas. There's lots of technology here. We are international friendly. And so this is just a little information about Kilgore College. We're a small school. We're close to Houston, but we're closer to Dallas. So about 2 hours away. Um, you can find a quiet place to study and focus on things that are important in your education. And there is definitely an advantage to being in a small town, that quiet atmosphere, but it's close to the city, so you can travel and go where you want to go and when. So we're going to talk about just some ideas of what programs we offer at Kilgore College. We have both workforce and transfer programs, and for those people who have never heard of a workforce program, essentially what it means is that you have the opportunity to get skills and training to get you into a job almost immediately after graduation or immediately after. We'll help you place into a job and we'll give you the skills that directly translate into what you can do in the workforce. And that's, for instance, help desk support, game design, software development, IT, and cybersecurity. All the things that you are doing now with ClockHacks. So I hope your projects are going well. I'm sure they are. I'm watching them come through. And this is an exciting time for everybody. But at Kilgore College, we're international student friendly. We have a vibrant international population. It is easy to make friends. And Texas is a state that is, again, like I said, friendly, and it is adding information technology careers all the time and software development. So there's plenty of opportunity here. The one thing that I want to ask you about is who you want to be, and who are you? And so um, there's this there's this guy, right, in the cybersecurity and IT field, and he's called the Machinator, and he makes guy or girl actually. He makes things, makes devices, he puts things together, he builds things, he engineers things to make them work better, and he invents. That's the Machinator, and that's the kind of person that, if that's you, we're looking for you to come here. Then there is this individual called the Guardian. He notices details. He looks for changes. He's ready to do cybersecurity analysis. He's ready to be a problem solver. He's ready to outsmart the enemy. That is the person who is ready to take on a challenge. So if that's you, we're looking for you. Then we have the Sentinel. This guy is a creative solution solver. He looks deeper than what's in the ordinary. He's a deep thinker, problem solver. I like to say he goes down the rabbit hole. So that is you. We're looking for you. And we have the Sentinel. He finds creative solutions, which is all of you guys, because in ClockHacks, that's exactly what you're doing. And he's going to look deeper than the ordinary. And again, building bridges between systems, that is a very important function. Um, and last but not least, one thing about Kilgore College, and as you go to tomorrow's session on how to talk to girls, you're going to need to know this because Kilgore College has world famous rangerettes. And this is a unique group of student young women who are on our campus that are there, and they are at every football game, and they are there to put on an amazing show. And so they're part of the culture at Kilgore College. And if you come here as a student, you will meet a rangerette and get to know them probably as well. So come and see us. Remember, your future starts here. My name is Danny Darden. You can email me, and we'll be glad to have a conversation. I want to hear about you and what you're doing. And now we'll get into the cybersecurity area of everything. And one of the things that happens in code is that we have code that we write, and a lot of times we'll start and coding a project and think, I don't really have time to create that feature or make it. And so what I need to do is I need to move on or build something else. And so we can easily get to this situation where we have what's called technical debt. And it means that we have a high degree of things that we're still left to do in a project. And unfortunately, as the programming project continues, the technical debt gets deeper and deeper. So one of the things that you want to avoid in programming is creating things that you have a to-do list that's very long. And so one of the things that often can get forgotten in that situation is cybersecurity. So I'm going to talk about today and actually do a demonstration and show you what could happen if you forget to basically check your code for errors, and we don't ever want to do that. But we're going to look and see kind of what happened there with that. And we're going to look at an attack that you may have heard of before. It's actually called the buffer overflow attack. I'm going to get right into that part of the attack, and we're going to look at this buffer overflow. And essentially, what we have is we have some source code, and I want to show you that source code here. And in just a moment, we're going to look at a piece of code that is called buff.c, and it is a little program that was written that can be any program that you write. I'll just take a look at it. Well, basically what this program does is it will ask the user what their name is, and it will wait for the input, and then it will call a function. And it will call a function with two things. One is the information that you entered in, and the other is a command, in this case, the word date. Now, when I create that function, what's going to happen is that two variables are going to be created that are 40 bytes large, and we're going to actually print out this message that the memory address of the first variable here and the memory address of the second is here. That's the command. And then we're going to take those values and we're going to copy them byte by byte over into another variable. Now, the thing about this particular code is that we could have easily checked to look at that value and run some type of test to see if the value is a certain length or if it contains something. And when you're looking in a program like JavaScript, for instance, you have functions available to you that more very easily will allow some error checking. But in this particular case, we're going to copy these values into some memory locations, and then we're going to print goodbye and our name, and then we're going to execute the command by calling the system. Now, all of the things that are here are very dangerous. You don't ever want to pass something to the system. You especially don't want to pass it in the sense that it is an untested value. We're going to take a look at what this program does. So it asks me what is my name, and I tell it, and then it executes the command date. So what we're going to do in this case is when we're a user of a program, we do not know how the program uses the variables and memory addresses. So as a user of the program, I am not able to see that stuff. So one of the things that I would do if I was an attacker and I was trying to basically exploit the fact that my program receives some information, is I might try to throw more information at it than I think that it needs. And so one thing that I might do, and you may have seen this before when you run your own program, is that after running your program at some point and basically it continues to run, and then something happened and you get an error that looks like that, segmentation fault. Now, unless you know exactly what a segmentation fault is, you might just dismiss it as, oh, that's not that important. I don't really need to know exactly what that is. It's not that big of a deal. I'll just rerun my program and maybe do something different this time. But what that segmentation fault actually means is that my program has tried to use a piece of memory that it does not have access to. And this is a bad situation. We never want our programs to be in a situation where they're using memory that they don't have the privilege to use. That means that we have done something bad. And in this case, what we have done is we have moved a memory pointer in memory way far away from where it should be, and we have tried to access another piece of memory. That means that my error handling in this particular piece of code is absolutely zero. I don't have any, right? And so that's my first piece of technical debt in this situation. I don't have any error handling at all and no program control. So, but here's what I get to do. I want to see what happens if I run this program again, and I'm going to put in some more values, but not as many this time, just a few more. And as you can see, I have put in all my values, and then I get the command date. So essentially what is happening is it's filling up this name variable. Now as a user, I do not know how big that variable is. I have an assumption that I can make based on the fact that it's someone's name, right? That it's probably going to be less than maybe 200 characters. I don't know, but it could be relatively small amount. But what we're going to do is we're just going to try and send some information over to it and hope that at some point we can maybe find that memory issue. So now what I do here is I count and I type the number A 10 times, and then I type the number B 10 times, I do that so that I can see exactly what point I start to write into the next location in memory. So at some point when I get the right number of characters, this command will change. And we'll see that output happen here in just a second. So I'm just going to give it another. Now this time what I did was I did 10 of each letter. And we're just going to see how far this goes. Remember, I'm a user and I don't know how far it goes. That's my segmentation fault. I put in more characters than I have memory for. And notice what it says. Goodbye, A, B, C, D, E, F, G, H, I, J, K. And then here's my command. So I've definitely overwritten my date command. And I started at about the seventh or eighth E. And then look here. I have this issue where it tried to execute my command and it said that's not found. So what I've done is I've actually um, found that I could insert a command into this variable name, and maybe I could do it. So not only am I overriding a buffer, but I am executing a privilege command as a system level user. So what I did here was I appended the command ls on the end of that, and so I know that if I get that boundary just right, that ls command is going to execute. And sure enough, I'm seeing two files that are in this folder. And I'll go ahead and do another command. Actually, any command you could think of, you can do. I'm going to write in who am I? And it will tell me my name. Actually, I got to run my program first. Then I'm going to type in who am I, and that is a Linux command that actually asks for the user's name of the person that's executing the program. And notice it says executing command, who am I, and there's my name, zero cell. That's what I go by on the computer, and it shows me that name. Now I can do any command that I want to at this point, now that I know the exact place where that buffer overflow occurs. Now what I want to do here is I want to go ahead and basically type out the source code of our program, and I'm going to use the cat command to do that. And notice that that didn't exactly work the way we had intended it to. So I think what I did was I didn't have enough characters in my variable, so I'm going to go ahead and make sure I get enough. And it executed my command cat, but then it just hangs. And one of the reasons why that happens is because it's actually not designed to interpret spaces properly. And so I can use a little trick that I have to tell it that there's a space. And I'm going to use this little thing called $ifs. That looks like it is a special command that is a space. And whenever the system sees that, it interprets it as a space. And I'll just go ahead and instead of doing that, I'll just go ahead and ask it to give me the source code. Okay, that did not work. Let's do another command. We'll do the cat and the CPU info. There we go. Now it has taken that information and it has interpreted that as a space, and it would be the same thing as if I typed in cat proc CPU info. And that is the information right out of memory about our CPUs. And that can be, if you start getting some ideas here, you can see that I can put whatever I want in that. And that brings me to the next and last demonstration. And I'm going to show you what would happen if I were to take that to maybe the next level and look at, well, we're going to look at a virtual machine that I have here. Now this is a little bit of an advanced topic, but it's what we learn in our cybersecurity arena, so you can get an idea of what's happening. So there is we could take that very same idea of the buffer overflow attack, and we can essentially go in and look at a program that's called Metasploit. All Metasploit is, and it may sound like it's bad or something else, it's just a way that people have gone to test systems, and they put different exploits in their system. And I'm just going to show you what this means as far as if you have code that's insecure in today's environment. It's very possible that that code gets deployed, and even if it's just been a couple of days that it's out there, we can see how easy it is to attack the code. Now, um, this particular exploit is a vulnerability that is not necessarily a buffer overflow. It kind of is. It works about the same way, but it was a specific string of characters that got read at the login prompt for an FTP service that actually gave someone a root shell, and that means that they can do anything they want on the system. And so this particular exploit was in the wild only for, I believe, 7 days. So it was not in the wild very long, but it is still an extremely um, bad exploit, and there are still somewhere systems that are running this code. So if you release code that is not secure, you can be in a very big problem pretty fast. So we're just going to use the search tool, and I'm going to look for the vsftp exploit. And I happen to know that I have a server that's running this particular software. So I'm going to go ahead and use this software, use this exploit. I'll need to tell Metasploit where my target is. And I believe it is at this address. And then we just issue the, oh, it's set. We'll run the exploit. We're doing our buffer overflow right here. And we have access to the remote system. So that is the danger of having code that does not check for the input that it receives. If you start releasing code that is not checked, you can cause a lot of errors. So how do we check? What do? We need to put in code that actually will check for the length, or we need to check for the fact that we have written the memory value that we shouldn't have, or we need to check to make sure that the characters that we expect and that we can handle are the ones that we actually receive. So whatever you do, check your code and develop good error processing techniques. That is the number one way to protect your code and your assets is how you actually build and create your programs. So I want to thank you for your time. I want to wish you the best of luck in ClockHacks, and I hope all of you have wonderful careers, and I hope to see some of you in the fall and spring. If you need any information about Kilgore College, you can email me, ddarden@kilgore.edu. Thank you very much.